Okay, so good afternoon. This is Chuck Barjon with the National Association of Invasive Plant Councils, and we are hosting the webinar today on unmanned aerial systems and vehicles. And this webinar will be recorded and made available with the other webinars on the NA-IPC.org website. We'll try to get it up and available later this week. If you have any questions during the webinar, there is a questions box that is on the control panel, and you can type the questions in on there. And then at the end of the session, we'll go through and answer those. If you have any problems hearing John or anything else during the webinar, you can also put those comments in there as well. We'll be monitoring those as the talk goes on. So with that, I would switch it over. Like to introduce John Morton, who is a biologist with the Invasive Species Management Branch of the Army Corps of Engineers, and he's based out of West Palm Beach, and he's going to talk to us about some of the new things that they're doing with unmanned aerial systems and how they're being used for vegetation mapping and restoration. So with that, I will turn it over to John.
All right. Good afternoon, everyone. I appreciate the opportunity to discuss some of our work that we've been doing down here and throughout Florida with some of the UAS systems. I do need to apologize. Chuck is gracious enough to be able to sort of man my presentation from his office because I was unable to install this webinar software. So if we have some discussions between ourselves about what slide we're on, please forgive me for that. But I'll go ahead and get started. So the basis of this is just to sort of give a description. First, I'll do a little history of our involvement with some of the UAS, UAV systems while we got involved, and we'll proceed into some of the work that we're doing now. So we can go to next slide, number 2. So the need for unmanned systems, at least within the Corps, sort of started with our need for more available high-resolution imagery for some of the invasive species work that we were doing at the time, and some of the environmental restoration work that we were doing, and that we also saw some future need for. We needed high temporal resolution, and we needed it to be sort of be able to acquire it quickly and to turn around for our end user. Because at the time and still today, we're working on wetland systems or lake systems in Florida. We needed it to be waterproof, so we could take it off and land it from a boat, or just take it off from a levee, let's say, and land it close to the levee but into the water. We needed responsive to users and a sufficient payload for future development, which we have on. I also believe one of my coworkers, Victor Wilhelm, is on the phone as well, and Victor is our image processing guy. He's really the brains of the internal system of this aircraft and has helped to develop it over, I'd say, though I'm not sure if Victor will be able to, if he does have audio capability.
You're too fine, John. Thank you.
Okay, good deal. So Vic's on as well, and he can help me with some of this stuff as far as the internal mechanisms of the plane. So we'll go to the next slide, Chuck. So our program mission with this was to provide a reliable data collection tool to support aerial mapping and environmental reconnaissance missions with the Corps. And you can see there launching it off the front of an airboat. That's sort of how this system was developed with the University of Florida, and I'll get into that. Next slide, please. This is just you know, traditionally, those of us who work with satellite imagery a lot and or fixed wing acquired imagery, you know, we know our limitations. We're used to being able to you know, use something like Google Earth, use something like the old DOQQs and whatnot to be able to get maybe 1 meter resolution. Yet, you know, 4 or 5 years ago it was 2 or 3 meters. But we needed something a little bit more than that. So you can see our system there on the bottom right of that slide is sort of, we wanted to take a large area and be able to dissect it a little bit with a little higher resolution imagery. Next slide, please. This is just a brief history. It started with ERDIC, our research sort of branch of the Corps. Their involvement with USGS and the University of Florida within the Jacksonville district of the Corps in 2005. We contacted those guys at UF and through ERDIC, and we were able to set up a CESU to be able to get those guys some funding there to help us with that. At the time, University of Florida had a developing micro UAS type program, and we were able to find some students that were interested in that, or should I say they were, and help to develop the airframe and the payload, which is sort of 2006, 2010. We were ready to transition, hopefully transition into full operation mode. And by 2011, we actually, our colonel at the time designated UAS branch within the Corps under operations under our Hydro Survey Department, which is where Vic works under. 2012, there was some new payload developments. By 2012, 2013, we were really fully operational as sort of a turnkey, if you will, production. Since 2013, really in 2014, Vic and his staff have on this metric payload, and we've also tried to increase support for other customers beside invasive species management, which we'll talk about. Next slide, please. This is just sort of some slides that Vic helped put together that show sort of the mechanisms of the ground station unit, of the unit that actually controlled the aircraft when it was in the ground. We went from, you know, there probably was a picture before of just a laptop out on the table somewhere, you know, in the middle of some swamp or on some airboat. But we've been able to get it, you know, sort of cut down into a system that can be deployed into the field, can withstand environmental conditions that were asked of it, and it's fairly ruggedized. To the next slide, please. So the current version is fully encased in a, you know, waterproof or shockproof Pelican case. All the internal mechanisms, all the wires are sort of hidden, and they made it a lot cleaner than when we had it 4 or 5 years ago. It's self-powered, got communication boxes, another external screen for somebody other than the ground station operator to be able to watch the flight and the flight progress as we go through a mission. Next slide, please. The airframe evolution, as I talked about, you know, the 2006 to sort of 2010 was really the development of the airframe and the components within. The upper left airframe, the Polaris, was designed by a student at UF at the time, and sort of as they cycled in and out, we got new ideas, and we learned from failures, I guess you would say, as to how to develop the next aircraft and to get it to the system that we needed for field use and for, you know, out in the middle of a swamp use. And by 2010, they had developed the Nova 2, and that's really close to the airframe that we're using today. Next slide, please. There you can see the Nova system, the plane as it is today. Next slide. And the components are the ground station unit that's up in the top left. The plane breaks down into a tail rudder, into the wings, into the fuselage. It can be packed into an airboat. It can be packed in Pelican cases and shipped overseas, as Vic and his guys have done. Although it can be a little brittle at times, we try to make sure that we don't damage the aircraft in our transitions, ingress, egress out to a job site, and it's held up well over the years. Next slide, please. You can see it fully encased. This is slide 11, where it designed again another Pelican case for the fuselage, and for also to hold some a couple of batteries. They are 6-cell lithium batteries, and we do use the autopilot system that we have used throughout has been Petrol Autopilot by Perseris Industries out of Utah. Next slide, please. So it is fully autonomous. We basically take off and land it by hand, although it will do essentially both autonomously. But once it's in the air, it is controlled by that ground station unit by an autopilot software program. It's about 2.7 meter wingspan, 15 or so pounds with a full payload in it. These numbers may have been adjusted a little bit since this slide was put together, but you can get about 750 acres per flight at a 300 meter altitude, which would give us somewhere around 3.5 centimeter resolution imagery, as we'll look at some images in the next few slides. The second block of the Nova, we could get about 60-minute duration flight, and up to the Block 3 on 90-minute duration. That seems to sort of come and go with the improvements in battery technology, which I would assume that would get better over the next future or upcoming future. Next slide, please. So the mapping payload details, and Vic can really discuss this more in depth, certainly a lot better than I can, but I'll just try to hit on the points. It's the camera body is a Rebel EOS T2I. It has various sensors in there for positioning, for advancing shutter speeds, as far as tracking back and forth to the ground station. Next slide, please. This is a standard mapping payload, is another Rebel SL. The positioning on this sort of is an upgrade with a Novatel OEM star, and it does back in. Next slide, please, which is 15. I'm not sure if this will show on Chuck's end of things, but maybe if you click on it, Chuck, but it should show a takeoff from the front of an airboat. If it doesn't, I apologize, but it's basically just a hand-thrown launch with the pilot, who's wearing the white hat, standing up. As soon as the aircraft leaves the launcher's hand, he takes over the controls, puts it up to altitude, and then we're able to control it from there, base station. The airboat that you see was sort of a neat side detail. We did customize this airboat by Diamondback airboats up around Beach, Florida, for this operation. So we had a lot of plug and play, had some inverters on there. They did a really good job of sort of fabricating some different mounts and whatnot, so we could fly this thing out of an airboat. Next slide, please. So this is just a little image of sort of how we do these flights as far as the mission is composed of. They're essentially just transects that are spaced both east and west, or X and Y from each other on a certain distance to provide enough overlap and side lap to be able to process the images when they're all done. Next slide, please. So this is just a zoomed in version of that green square that was on the previous slide, and that little white circle in the upper left of the slide is the airboat that we were launching out of that day that it did pick us up. Next slide, please. You can see it there. We're in an area called Fish Eating Bay in Lake Okeechobee, and most of those round floating leaf plants that you see there are water lotus and combined with probably some floating water lily nymphea in there as well. The next slide, please. You can go on to slide 20. So we do have some constraints. We can only fly in approved airspace. This is sort of changing as we're talking with some of the new FAA regs. Below 1,200 feet is sort of our ceiling. We have to be 5 nautical miles outside of any airport, even a development small airport that's out in the middle of a ranch somewhere. You know, we still have to stay 5 nautical miles outside of that, and 30 nautical miles for large airports. So for us, it's West Palm Beach, Fort Lauderdale, Miami, Tampa. Flights in this airspace most of the time require a COA from the FAA. We do have to have an airworthiness, which is that AWR qualification level 3. To avoid flying over people, roads, home, etc., like that. So that can be a challenge as you're, you know, if you're on something like, let's just say Lake Okeechobee, where there is development pushing up to the side of the lake, or at least to the side of the levee. We have to be aware and conditioned about where we're actually sending the aircraft over. And we have to keep line of sight. So that typically is 1.5 kilometers. But we do have to always maintain line of sight with the aircraft. Next slide, please. That's just an image of our national airspace. We can fly in Class G, but we still have to maintain that 300-meter ceiling. So next slide. So the applications of this, we'll move on to slide 23, I believe, Chuck. Within the Corps, it's pre-construction, active construction, and post-construction monitoring. That's a big deal within our engineering and our construction branches. Asset infrastructure management, just to keep an eye on things. But the bottom 3 are really where, at least within our branch, we've devoted a lot of time, energy, and funding to, is the invasive species surveillance and monitoring, the variety of vegetation mapping, both invasive species and native, and environmental restoration / engineering, as we'll talk about as well. Next slide, please. You can go on to slide 25. So the first project example we can talk about, and I hope everybody still can hear me and everything well. Like, again, I apologize for not being able to connect like most people are, but we'll talk about the Fish Eating Bay area on Lake Okeechobee, which is in Glades County. It's on the western Okeechobee. At the time when we were doing this, is a nice broadleaf type marsh, very shallow marsh, about 3 feet deep in average. Next slide, please. So the red box outlines about a 240-acre section that we were targeting, and we were targeting based on some new plants, a new species that we had found the first time in Florida. We'll talk about in a second, and we wanted to see sort of the matrix and how it was interacting and affecting the communities, the native communities that it was growing within. Next slide, 27. So that's a zoomed in version of that target area in red that we saw in the previous slide. Next slide, please. So the species we're mainly interested in and seeing if we could find it, and not only just find it, but give sort of a spatial reference and to the degree it was mixed in with the native communities, was a species called Lusiola subintegra. I think now it's been given the common name of tropical American watergrass. It was first found in Florida at this site in Lake Okeechobee. It had been recorded in a herbarium that was in the Tampa herbarium, but the specimen had been found in Cuba back in the 60s, but this is the first time it was discovered in mainland Florida. I mean mainland North America, and it was the first sighting of it was in Fishing Bay in Lake Okeechobee. It's a perennial grass. It can float these big, can make these big floating mats like you see here. It's also fairly happy with its feet dry, but it was alarming at the rate it was expanding. So we were trying to get a sort of an idea of the spatial coverage that it was at the time. Next slide, 29. So you can see I hope you can see this. The Lusiola is those sort of striated lines that you see mixed in. The other dominant species that's within there is American cupscale grass. But the Lusiola, when we looked at it from the air, and we had seen this in helicopter surveys, it just had a different growth form to it, and I was fairly confident that we could find this via and indeed, as it was growing, or when it was growing at the time, we could certainly see those striations throughout the marsh that it was growing in. Next slide, slide 30. It was also growing in and around some open pockets of a lot of floating leafed and floating plants, and the dominant floating plant that this slide shows is water hyacinth and water lettuce. The lettuce is a little bit lighter green. If you can see that, the hyacinth is a dark green, a very dark green, and it also some of the brownish yellowing individual blades that you can see, individual leaves that you can see from the water hyacinth were a result of a biocontrol mite that gets on it from time to time. But you can also see the striations of the Lusiola that were still by. We ran the analysis on the imagery. This is the first time that, like I said, it was 250 acres, so it wasn't a giant area, and we only had about 6 or 7 different species that we wanted to delineate. But this was performed in Envy at the time, and what we found is the Lusiola at that point in that 250 acres was taking up about 15%, or was composed about 15% of that image. And we went back and ground truth certain sites, and there were some noticeable errors in places where it got mixed in with the American cupscale grass. But for the analysis of this image in general and throughout the whole fish-eating bay site, not this 250 acres, we found out that the Lusiola was covering about 15 to 25% of the total available area. And that was just in about a 2-year growing cycle, or 2 years from the day that we found it until this imagery was taken. Next slide, please, which is 31. This is just sort of another depiction of that within Envy. The upper right-hand section of this image, really the concentration of the luceola that was growing in that. But we can also see that we had a lot of decomposing material, which is what's outlined in orange. And the reason taken about 6 or 7 weeks after a floating plant treatment, a herbicide treatment for water hyacinth and water lettuce. So we can also, and which we'll discuss later, we can also use that to monitor some herbicide controls or herbicide applications that we found out in the future. We'll move on to the next slide, which is 33, and we'll talk about another project that was on Lake Okeechobee at the time. Both of these projects, the reason we chose Okeechobee is the Corps was heavily involved and still is as in invasive species management, especially floating invasive management, and mainly water hyacinth and water lettuce on Lake Okeechobee because of navigation and flood risk management and concerns. So we were able to devote some of the Corps' floating control budget, our RAG budget, to these projects. So we'll go to slide 34. Eagle Bay.
Hey, John, before there was a few questions that popped up, and I figured it might be better to address them now than
Okay, sure.
Yeah. So the first one was, does the imagery use spectral analysis? And then, and kind of related to that, do you use any filters for the camera or a multispectral camera at any time?
We can discuss that, and I'll let Vic jump in anytime. The image is 3-band RGB imagery. We do have an infrared filter that can be an infrared filter lens that can be put on the camera. We didn't do that, and I don't believe we had that available at the time when we did that first fish eating bay project. But we have flown no hyperspectral UAV platform yet, but we have flown RGB, and we have flown infrared on projects after this project. And Vic can probably discuss the infrared a little bit more.
Yeah, so the infrared camera we used was essentially a DSLR where the IR cut filter is removed from the camera body, and then depending on what we're trying to do, we'll use a blue cut filter, and then use the blue channel of the camera to capture the infrared energy, and that kind of gives us a hacked CIR camera. And then alternatively, we could use a visible cut filter on the camera lens, and then pass only infrared energy, and essentially turning the camera into a infrared only camera. I think that might answer the question.
Yeah, so something related. It says you sound like you used NVI and EV to process the images. How did you mosaic the separate images together in the first place? And then they said Pixel 4D question mark.
So we process the imagery. Excuse me. We process the imagery using a software called Photoscan. There's some other software that we can use also. And that's Correlator 3D and Pix4D. But at the time this project was done,
it was all processed with the Photoscan. And
I'm not sure I understand
the question of
if the imagery is 4D. Is that the question?
No, I think they were asking if you use the PIX 4D software.
No, not for this project.
So 2 more, and then we'll move on. How long did it take to cover the 250 acres with this unit in the field?
At the time, that was just one flight. Less than an hour. That was one of our first projects where we really wanted to, to get as best imagery as we could and scattered across the that whole square, that whole 250 acres. So we flew a little tighter lines and probably we needed to, but we just wanted to make sure that we got the overlap. But we did it all in one flight. Of course, now today, moving forward, I mean, that was about 4 years ago. We could cover 250 acres in a 20-minute flight based on, what kind of head or crosswinds we were flying into.
So one more question, and then I'm going to mute my mic, which might be part of the problem. Is the NV software you do a supervised or unsupervised classification?
We've done both, and we've done it in ArcGIS as well, or early on we did, as well as NV, and you can do it. There's some plus and minuses for both. We've digitized it totally fully out ourselves behind the computer, as I'll show you in some next slides, and we've also done the training data sets and sort of let the models and the algorithms run it as well in NV. So we've done both with mixed results, and we'll talk about some of the new classification technologies that we're working on these days, still with the University of Florida, in some future slides.
So why don't you go ahead and go on, John?
Okay, I hope that answers the question. If not, we'll have our contact info at the end of this presentation. So, slide number 33. We went through Eagle Bay. I'm kind of behind on my slides right here. Let's go to 35, Chuck. So this is an outline of the project at Eagle Bay that we flew. This is about 3,100 acres that you're looking at, and we're really concentrated into the sort of the south quarter or south third of this marsh. Another broadleaf emergent marsh up on the north end of Lake Okeechobee. But as I mentioned, the Corps is responsible at the time, or we were responsible for floating invasive species management in and around, not just in the open water sections of Okeechobee, but in the marsh areas. Well, this marsh sort of expanded during a drought that we had back in 2007 to 2009, and in turn, a lot more of the emergent vegetation started creeping out, sort of on the slope of the bottom of the lake. Created some very, very nice habitat. As it did, the endangered Everglades snailkite started returning to this area and nesting, which presented challenges both from a floating plant management. Some of the issues that we had managing floating plants in and around snailkite nests, but we also were trying to keep the habitat that it came back, or keep a lot of those native species that it came back post-drought, and we didn't want the floating species and invasives to have impact on that. So the next slide, we'll zoom in and look at this fringe, sort of the outward fringe of the bulrush cattail line on this area, which is, we'll go to slide 37. The majority of this, the dark green on the southern end of this imagery, on this image, is water hyacinth. On the upper end is water lettuce mixed in with some different emergent grasses as well as bulrush. Go to slide 38. So we were tracking this. We flew this project 3 different times during 2012, and we were not allowed to go into this area based on snail kite nesting restrictions. So we were a little conservative not to push the buffers. The 17 active nests, you can see those buffers outlined around those individual triangles or the snail kite nests. So we're mandated to stay out of those buffers with herbicide treatment. But we also, snail kites more to the area and nesting, so we wanted to sort of see how these, how our floating species, hyacinth and lettuce, were expanding in the area without the aid of herbicide. So we flew it in March 2012. This is, the yellow is 10 digits, or digitizing ArcGIS based on the imagery we received from the UAV flight. So in March there was 142 acres with 17 nests. Next slide, please. By July there were 537 acres in this area and 29 nests. So that really limited us where we were able to go in and do herbicide treatments. We got approval from the state, from the state FWC to Fish and Wildlife Commission to go in and actually go inside of these active nest buffers and start treating the floating weeds that were in there. Next slide. And by September, there were 17 acres of hyacinth and lettuce left, and only 1 active nest. And the kites were at the very end of their nesting season. And so that, being able to fly 3 separate times during that summer, or from March to September, really allowed us, one, to show how these plants could expand if left untreated, and also be able to show how we didn't impact snail kite nests, but how they could be impacted the following years and the following seasons if no floating weed treatment was done inside of that. So next slide, please. We also, during this time and every month, there's an interagency team of biologists that fly Lake Okeechobee looking for just floating weeds and doing an average count per area for water hyacinth and water lettuce to direct herbicide crews to. And it's always interesting when you have hard data compared to aerial survey data for people that have done it. But so in March, our group estimated there were 967 acres there, 168 acres in that Eagle Bay Marsh area that we flew. Digitized out, it was 142 acres, so that's not too bad. But in July, the group estimated there were 1,310 acres in that one Eagle Bay area. Or in actuality, we flew the day after. We flew the UAS the day after they flew with a helicopter and digitized out 537 acres. So that sort of reiterated the fact of how our methodology behind aerial surveys, and depending on who's in there at the time, can vary. But it also can vary on the elevation of sort of priority areas when it comes to invasive species treatment. I mean, 1,300 acres looks a lot worse than 537. So that sort of, it helped us sort of calm down people's perception of how bad it actually was out there compared to what we found out after. We'll move to the next slide. And I wanted to discuss this. There's a few slides on the object-based classification. Somebody mentioned the unsupervised versus supervised. We realized that doing this, trying to hand digitize out or trying to just use ENVI with this high resolution imagery was more than as a staff we could handle or had the expertise to handle within the Corps. So we reached out to Dr. Amr Elram he's a geomatics lead at the University of Florida, which is his office is at the Gulf Coast Research and Education Center in Plant City. And at the time, he had a postdoc student, Rashawn Pandy. Now we have Tao Liu, who is actually another postdoc working on this. Tao may actually be on the phone now, but I'll just go through this. We can talk about this for another hour, and that's probably not what you guys want to talk about today. But this is sort of where we're gearing our efforts and our funding to be able to interpret the images that we're getting in a way that we don't have to hand digitize out everything, and then we can model and use algorithms based on training the computer or training a software to be able to pull out, to extract the data that we want extracted from it. We may not care how many acres of this X species plant is. We're just worried about Y. We're just worried about Z. But we're able to do that, or we're able to get to where we can do that based on different classification methods. Next slide, please. So an object-based, excuse me, Chuck, can you go back to that previous slide? I'm sorry, I skipped right over it. So our goal is slide 44. Our goal was to map invasive plants using spectral textural classification. So identify, and this is Dr. Almers and his team, that their expertise, and this is why we went to them, is for them to tell us what the best spectral and textural features and what segmentation scales we needed to use for this. Let's test these different machine learning classifiers. Let's use some of the new developed and some of the continuing developed neural networks that we can sort of teach these computers and this software how to help us better tackle the resolution and the scale of the images that we're collecting. Next slide, please. So this is just showing using object-based some of the work Rashawn did and Tao's still doing based on different scales of segmentation, where it actually is instead of just using a pixel classifier, we're using an object and the pixels around that object to be able to segment and classify it out. Next slide, please. So the upper left is a section of mainly the floating leaf or the emergent leafed species is water lotus with lettuce up under it. You can see some of the white flowers of the lotus, and we use this at different scales to see, okay, what is the scale that we need to be able to pick out the water lettuce that are under this, under these native communities, so we can at least quantify it with some degree of accuracy that we can accept and be able to determine the spatial distribution and the area that this invasive is sort of taking over underneath the canopy and within the canopy of some of these natives. Next slide, please, which is 47. So the guys found out that scale level 75 was better to separate most classes, but scale level 40 was found that, maybe breaking it down just a little bit smaller. And if we're looking at just community level, let's just say a patch of willows that are within the image, or a patch of cattails that you can visibly see that there is, it's not a mixed community, then maybe 110 to 75 was kind of where we wanted to be, and we didn't need to go down to 15 or to really separate those larger communities. Next slide, please. So the result of the preliminary study at Eagle Bay, let's just say L40, it separated patches into a mixed species area. I mean, it did a mixed class area. Excuse me. It may have mixed the species together, but we were still able to kind of pull out which ones that we wanted from that fine scale of L40. Whereas if we go up to 300, it was just a little bit too coarse to be able to get the level of detail that we were talking about. Next slide. So we took that and ran some training data across this entire block of the image, and basically what we did is just ground truthed. Each one of those points were ground truthed based on the dominant species on that point or within that point, and we tried to keep it as, I'm not sure if you can read the upper right hand section, but we tried to keep it as sort of rudimentary as possible. We didn't want to break it out into 40 different species, but we tried to keep them as communities if we could, and then pick out certain things that really stood out, such as water hyacinth, such as water lotus, water lettuce, and so on. Next slide, slide 50. So the broad categorization, all right. So we know that the yellow in the upper left-hand side, it was able to determine that was some asphalt or some roads. It was actually shell road, and then we were also able to see that to delineate the water out of there. Although we did have some area in, you can see in the upper right-hand section where it did show that there was some road out in the middle of the lake, which wasn't the case. Next slide, please. So maybe, and this may help to further illustrate what we were up against. At the class 75, which was, but 75 to 40 is what we deemed that we thought we would need to be able to delineate everything out by species, and you can see the difference in between the 40 and the 75 on the right hand side, and then find them on the bottom left. Next slide, please. To slide 53. So the accuracy assessment based on some of these methods that were used, based on and used against our ground truth data, we were able to get almost a 70 or a little bit over 70% accuracy with the SVM as compared to just a pixel-based analysis. And we've expanded on that, and that's what Tal's working on a little bit now, and I'll briefly discuss in these next slides. Slide 54, please. So one of the things that was tough there is distinguishing between water lettuce, which is an invasive species, and water lily, one of the nymphaeas, because they certainly had, depending on where they were growing within that marsh, had a lot of the same, the pixel colors were very much the same as you can see in that slide. Next slide, please. And at times they were mixed, and especially if a boat had just driven through there where maybe the lettuce had water on top of it, or maybe the lily had water on top of it, we struggled with figuring out how to delineate those two. Next slide, 56. An area that was predominantly water lettuce, so we could see, okay, if it was close to open water, or if it was, let's say, the littoral edge, we were quite confident that it was probably water lettuce as compared, without any ground truth, and as compared to the nymphaea, which was growing inside that littoral edge a little bit. Slide 57, please. And that also shows the water hyacinth. Although we did have some problems with water hyacinth mixed in with the native smartweed. Next slide, please. So lettuce and lily, they were spectrally similar. I mean, lettuce is a little bit more yellowish. That can depend on, sometimes it can depend on seasonal, but most of the time we can we're quite confident that it's a little more yellow as far as the pixel goes that it probably is lettuce, again without any ground treatment. Most areas were correctly assigned, but some were confused. Again, especially the lily and the smartweed when it was growing within water hyacinth. Next slide. So what Tyle's working on now, and what we hope to work on in this next year, is using some of the new technologies on the neural networks, as far as specifically looking to be able to distinguish, not just using object-based and not just using a pixel-based, but sort of combining, trying to find a combination between the two. Next slide, please. Slide 60. So the training data on this set were extracted with 8 centimeter resolution imagery. 32 by 32 pixel window were extracted from each training polygon. And the label of the object is used to assign the label of each patch within that polygon, which we'll see on the next slide, slide 61. So, and we have this one data item where X is the pixel value and Y is the vegetation type, and this is just one example of a lettuce item. We can go to slide 62. I'm sorry. So Tile extracted over 930,000 patch samples from the training polygon, and of that, 60,000 were systematically selected and shuffled, and then split into 3 parts. So 6,000 were used for testing, 4 for validation, and 50,000 for training. So there's a ton of work involved in, trying to sort of get this image where we can read it and where we can interpret it. And we next slide, please. The second training or second testing set that I believe he's working on now, I'm not sure if he's through with it, involved that same process, but over 373 random points across the image. So the work is quite tedious. We can skip 64 and go to 65. So using the first data set, the convolutional neural network achieved about 79.88% higher than the best accuracy of the object-based approach. However, to make the comparison more fair, they also ran the CNN model on the second testing data set. So I guess we can stop there. I'll talk about one more quick project, and I don't know, Chuck, if there were any questions associated with that project.
You've got some more general questions, but if you want to go through this, and then we can do the questions when you get through with it, that'll be fine, I think.
Okay, cool. So slide 66. We wanted to take both of the projects that we've really tried to spend a lot of time on delineating wetland communities, and especially, or specifically, delineating 3 or 4 different invasive species from that wetland system. That sort of has been revolved around sort of what those 2 projects discussed earlier were focused on. We also wanted to try it on a drill system, and specifically an area that we're working on for NRCS. We do a lot of weed work, a lot of invasive species and restoration work for NRCS across the state, and ranging from the treatment of Brazilian pepper, melaleuca, lygodium, common fern, and one of the main ones is Kogan grass. And I felt like that we can sort of use what Amer's team has built on to be able to pull something like Kogan grass from maybe a 1,000-acre pasture, let's just say, and delineate how much coverage that Kogan is invading, and also get some acreages, and also check on be able to have pre and post treatment data, herbicide treatment data. So we chose this Bluehead Ranch project in Highlands County. You can go to the next slide, 67. It's about 18,000 acres of a wetland Wetland Reserve Program conservation easement. Next slide, please, 68. It certainly had Kogan grass and other invasives scattered through, but that southeastern corner was really the one that I wanted to try to target with the flights and also with analysis. We can go to 69. My apologies for not having a mouse, but I don't know if you can make out, and I'll have some more slides following, but if you can make out some of the distribution polygons of or patches of Kogan that are scattered throughout that image. There's sort of that lime north end and the southeastern or bottom right section as well. Next slide, please. Maybe these next two slides will help. But I was just trying to show the Kogan patches that are scattered throughout this pasture. This historically would have been dry prairie, which has been converted over to improved or semi-improved pasture over the last 70 to 100 years. Kogan has really invaded it. So we'll go to slide 72. So first, after we flew the site and Vic and his team processed the image, of Amr's team, we wanted to look at, can we use some of these object-based classifications or pixel-based or a mix of the two to delineate the species of Kogan, and also at the same time to be able to map the wetland plant communities as well as we were doing this. So we picked a set of training data that ranged in different sizes, we tried to encompass different communities or all the communities that were showing in this section. I should have mentioned this was about a 2,000 acre block. And so we ground truthed all of these polygons with our training data. You can go to the next slide, 73. And we use the South Florida Natural Area classification system for that, for each one of those polygons. Not sure if you can be able to read some of those. Maybe slide 74 you can. Next slide, which will be 75. So this work is ongoing. This is something, this section, or these two images here were something that we were able to do, Vic was able to do in ENVI. We're currently working on the other classification system on this project as we speak. So I wish I had some updated images to show you. We just haven't made it that far yet. But the lime green, the highlighted lime green, just within ENVI, was able to distinguish the majority of those small Kogan patches, which may be, less than a meter squared up to, 2 or 3 hectares. We'll go to the next slide. So what Vic and his team also were able to extract from these images were some digital elevation models based on some of the point cloud data that was established or that was extruded from the images. So as you can see, as you would know within restoration projects, especially in Florida, it's so flat that at times if we don't have LiDAR data or we don't have great survey data, it's hard to know, it's hard to get a topography map and to know what plant communities that we want to encourage in certain elevation sets. So at times from the way we're able to extract from the image, we're able to see different elevation contours, which the image on the left, you would see it and you would think it was very flat, but when you're able to break out these surface models or the elevation models, you're able to see that there is a levee around it, and there's some fairly substantial relief around. So this definitely is something that we're exploring more when we don't have LiDAR on the site to use for restoration work, especially when dealing with NRCS wetland restoration projects. Next slide, please, 77. So the future I think there's a lot for us to be for us to build on. We've taken some steps back, but I think we've taken more forward. Excuse me. Slide number 78, please. Next slide. So even from the core, I mean, when you're looking at restoring a wetland system or restoring a system that already has, and as is in Florida, most of them have dikes and ditches around it. We're able to look for, get some sort of estimation where there's repairs that are needed within some of these contained wetlands that do have dikes and berms around it, as you can see on this surface model here. Next slide, please. And we're also able to extract out a profile of the elevation that there. That one we found out was about a 1.2 meter washout, which was around the road or levee that, without going on site, may not have known that it was there. Next slide, please. 80. Again, this is some of the point clouds that you can be able to adjust some sort of surface or 3D extraction from, that we hope to be able to build on in the future for our restoration efforts. Next slide. And this is more in Vic's alley here, is expanding on the metric payload, to be able to, potentially add some hyperspectral sensors in, maybe at some point a LiDAR sensor. Obviously, we want to expand on our infrared and to have that extra band, especially for species identification and seasonal identification. I really believe that our band will help expand on that and help increase the accuracy as we move forward. Next slide. We go to slide 84. These are probably more of the airframes that people are familiar with, and more probably for us from a fixed image standpoint or for a video standpoint. But these things are turnkey. There's not a lot of training that you need to be able to feel comfortable flying some of these multi-rotor aircrafts. They're a lot cheaper. You don't need the crew. You don't need a 4-man crew to go out there and use these things. You can get some great video. You can get some great still images. The battery life is probably not enough to fly a couple 100 acres a day, but if you have multiple batteries, you probably could. But this is sort of, we're moving to this side too, as just a readily deployed, let's go up and look at it real quick and not have to spend a lot of time behind a computer doing the analysis on the image. Next slide. You can move to the last slide. There's my contact info and phone number and email. I know if we didn't answer your questions today, please feel free to email or give me a call. And certainly, if I don't know the answer, I have a team of people that I rely on that do. If there's any questions, feel free to ask them now, and I really appreciate the time. Thank you.
Okay, John, so we got a fair number of questions here, so I'll just go through them one at a time, and we'll just see where we can get. And again, this will be recorded and on the NA-IPC website if anybody's got to cut out. So the first question is, has feature analyst OBIA extension in ARC been used for feature extraction?
And Vic, you can expand on. Go ahead. I'm sorry.
Go ahead, John.
I was just going to say, early on, I'm not sure what was the extension after feature analyst, Chuck. There was a number in there that I'm not familiar with.
OBIA extension.
Now, I don't know what that is. Vic certainly may, but we've used feature in spatial analysis within ARCs, especially early on smaller projects to some degree of success. I know there's been a lot of work done on that in Florida, down in the Glades, and some work on Okeechobee, but we sort of moved away, I guess you would say, from ARC for just because the amount of data associated with this type of resolution, and having a machine that can process it, which we sort of fall behind on sometimes doing it from our laptops or whatnot. But it's certainly something that I can ask photogrammetry guys about if anybody can expand on that.
So I've not used the feature analyst object-based approach. I have used the the object-based module in Envy. The example that you saw of Bluehead was done just using a maximum likelihood classification of the pixels without the object base, and we found that more efficient.
Okay, so the next question was, and these are kind of going back to the kites, but was the kite using the invasive plant, or did the data show it avoided areas with the invasive?
You said the kite?
Yeah, I guess the kite's.
Yeah, so the kite will forage in the areas where the water highs. I mean, they're looking for snails. They're looking for really two species of snails in Okeechobee. One happens to be an invasive snail that they're feeding on now. But they will forage in the areas where their floating weeds are until a point where especially water hyacinth, because the wave energy is so great on Okeechobee, it can get in mats where it starts pushing over this emergent vegetation. And if the kite nests are close enough to the outer fringe of the lake, that wave energy can also damage kite nests. But yeah, the kites will forage within floating plants to a certain density, and then it sort of eliminates that area. That's why the state has worked really good with us, being able to allow treatments within those buffers, because they know how important it is for kite foraging and for nest success.
So, did y'all use the UASs to detect the kite nest?
We haven't, and the kites don't build. They're pretty poor nest builders. I certainly think you could use it for something like osprey nest, obviously eagle nest. They've used it down in the Glades for doing rookery detection for wading birds, big white wading birds that sort of stick out. We've been able to find a lot of alligator nests, but you can sort of see those from a helicopter, if guys are surveying for them. But there are certain nests that you could definitely find, but a kite nest I don't think would be one of them. They're sort of inconspicuous, and the bird just blends in so well to the habitat.
So the next question is, was a decline in the invasive as a result of the herbicide treatment linked in any way to the observed decline in kite nest?
That's a great question, but no, the kites were typically in late July. The kites are starting to wrap up their nest season, sometimes earlier, sometimes later. Like this year, for instance, they seem to be going later. They're moving into different habitats that are effective water levels, and that's sort of what got them that year. Is we rising water in July through September, which was helping the water hyacinth kind of push forward into the marsh. But the kites were about done when we moved the herbicide crews in there. And that was all, it was all coordinated with the kite biologist for the state and for U.S. Fish and Wildlife Service.
So, this question is, could you elaborate on how you were able to obtain a 1,200-foot COA?
I'm not sure I under. But ceiling?
Yeah, I guess if Thomas was still on, if he can explain that a little bit better, that may.
I can speak to that one, John, if you don't have an answer.
Okay, cool.
So the Department of Defense, we have a memorandum of agreement with the FAA that allows us to get what's called a COA notification in certain classes of airspace. In the Class G airspace, which would be up to 1,200 feet. And this area was in airspace where we could do that.
Okay, I think that's what the question was, because he followed up with the FAA COA. So is there training required to operate the UAV, and how much for the latest model?
I guess we can both stab at that, Victor. I know as far as the operation of it, that the Corps, we sort of had our own requirements. I mean, I think the Army, we tried to go by with what the Army was requiring out of their military personnel as far as operating the airframe itself, flight physicals, training time, stick time. But we also we went out to Perseris in Utah, sort of learn as much as we could the operation of the ground control system or the autopilot system. And there was just a lot of, quote unquote classroom training, sometimes happening in the field as well, but before we ever felt confident to go out on a mission of our own. I know Vic's team has put together more of a sort of a stringent training manual for the operation of the ground control station as well. But they're strictly core within the Jacksonville, our policies.
So I guess estimate on the cost, I guess, was the second part of that question.
I think I could speak to that one. So the system that we funded the research now, the students that worked on it formed a company called Altavian. They're currently selling the 4th generation of that system, and you can get a complete all-up system, ground control station payload, and airplane with control up 25,000.
You went out just a little bit. You said 25,000. Is that right?
Yeah, I think the cost is close to 25,000.
And somebody asked for the company name. Could you repeat that again?
It's Altavian. It's in Gainesville.
Can you spell it? I'm sorry.
Altavian. A-L Alpha Lima Tango Alpha Victor Indigo Alpha Nevada.
Perfect. Okay, so going back to some of the other earlier questions, it said it looks like you had cloud shadows in the imagery. How do you compensate for the shadowing?
And Vic can certainly elaborate on that from processing, but it's tough to find the right window. I mean, obviously there's certain, you can adjust some of the sensors and some of the settings within the camera, but you have to balance, especially flying over water, sun angle, early morning, afternoon, to eliminate the shadowing, and then you hope for between the 10 to 2 sort of time frame in a normal day, so you don't get that cloud cover or you don't get some images that are really vivid and bright, and then you have, on the next transit over, if the sun goes behind the cloud, then you have a darker image that's a little harder to adjust in the processing.
Yeah, it really screws you up. So just to elaborate on what John said is, essentially in South Florida, there's a very limited window to do the collection before the cloud comes in. And then once the clouds come in, depending on what you're trying to do, you got to make a decision whether you want to keep collecting or not. But for the classifiers, if you do all the training data in one area, let's say it's outside of this shadowed area, those classifiers are all thrown off in the shadowed areas. So you almost wind up having to have two sets of classifiers because of the change in the imagery. So we haven't figured that one out yet.
So, and you mentioned LiDAR, and so this is a question about LiDAR that may be outside the scope of this, but is there LiDAR that can deal with water, shallow water to approximately 1 meter?
There's not one in the UAS platform that I'm aware of.
I don't.
Okay. So going back to the COA, there was I guess there's a difference between private and public COAs. Going back to the agreement that y'all have with FAA that lets you do some things. And one question was, and I'm assuming if they meant y'all's group, but is this something that they said ERDIC, but I'm going to expand that to the Corps. Is this something that the Corps could provide as a service to other groups?
It's something that I guess we would have to define what that other group is, but there's been the core team has flown a variety of different projects for non-core customers, but they were still something, projects that we were funded to work on, such as NRCS, government project, or through another Army component, I guess you would say. Vic, I don't know of any privately funded project that the Corps has done, if that's even a possibility. You may have lost him.
No, I'm not. I'm trying to figure out how to use my damn phone. I'm not aware of one either, John. I don't even know if we have an ability to take funding from a private entity that I'm aware of. I can try to get with the lawyers, but I think there is.
Yeah, I don't.
I think the lab. Yeah, the labs might be able to do something like that. I remember hearing somebody at one of the labs allude to that. I can certainly inquire, but I don't think there is. At least not at the district level. We can.
Yeah.
So, and we'll make this the last question, but so I guess there was there's a new rule related to through the FAA that states that they're limited to 400-foot AGL, and that there's a requirement that operators have a small UAS pilot rating issued by the FAA as of August 2016. So I guess I'll make that question. Do y'all see some of the new changes related to, drones, unmanned aircraft, going to change things for the better or for the worse?
I think regulation's always a tough tough thing even for us. We've had a lot of times when we followed regulations, like if we filed NOTAMs, we drew in an audience. You know, we would see fixed wing guys come over and just because they knew we were going to be flying to check things out, which put us in some tough situations. You know, because we were in a lot of the ag areas in South Florida and Central Florida, we had crop dusters that you know, we became first name basis with them just because we had to let them know. I mean, I think the safety aspect of it, I understand it, and I think with more UAS in the air nationwide, not just in South Florida or Central Florida or wherever, you know, it's going to be a good thing. But the way that, especially in the private sector, maybe handcuffed by that, could provide, you know, could prove to be very, very challenging for future work on this scale, and even for us. I mean, we were sidelined for a while, right, Vic?
Yeah, we got caught up in some stuff that had nothing to do with the FAA. It was more like a Department of Defense intelligence oversight deal that did not deal with us specifically. That shut us down, but it was another regulation we had to deal with.
Well, and I mean, you know, the 30 nautical miles from the airports, I mean, that's a good bit of land that is, you know, this public land in conservation that you're limited on being able to fly over just because of the airport restrictions in South Florida.
Well, we can get to that. We just have to put in for a COA, and the way that works is when you apply for that COA, you have to work with the airspace managers that own that airspace. And if they're reasonable, you could usually come to an understanding that, hey, you know, you're in this really, you know, small piece of the airspace. And once they understand that, they're usually pretty willing to work with you.
Okay, so there are ways, and so as a listener, I missed that. So there are ways to get through those barriers in terms of distance to the airports.
Yeah, with the airports, with the airspace managers, a lot of times you're at their discretion of how you're going to be able to operate in that airspace, and if you'll be able to.
Right.
Yeah.
Okay, and one more question, and then we'll wrap this up. There was a question about interest in running high temporal resolution imagery trials on Kogon grass with prescribed burns.
Definitely, you know, there's a lot of species that we work on that I don't think this technology would ever help us out on, just because they're so hard to detect, or they're growing within a canopy, or they're growing within other you know, other communities or other just specific species that we just cannot distinguish from, even with, you know, trained eye and a lot of ground truthing. But Kogan is one that I think, at least statewide in Florida, I know in the Panhandle and through the Gulf Coast region, I'm not as familiar with some of the other communities that it grows within, but just the vibrancy of that species, especially post-fire. Now, I think it would have to be, you know, you would have to catch it when it's, you know, let's say greater than 6 inches tall, but I do believe you'd still see the footprint of that rhizome growth, even really quickly after a burn, especially if it was established Kogan. Now, if it was just seed Kogan that's just came in and doesn't really have an established system or a footprint, it may be tougher, but I think you could see it very quickly after a burn, given that it was an established population, and that it wasn't growing under, you know, like, let's just say a dense canopy of slash pine or longleaf or something.
I gotta agree with John. I'm not a biologist. I don't know what most of this stuff looks like, and stuff that John has tried to show me how to find. I can find Kogan. Kogan, I mean, it just stands right out, but it's got to be the right, you know, right time of year. But I'm able to find it pretty easy without very sophisticated cost efficient.
Well, great. Well, thank y'all very much, and thanks to all the participants. And we will be doing another one of these in a couple of months. So look out for the announcement. And this recording will be available hopefully later this week at NA-IPC.org. And thanks, John and Victor, for y'all's presentation. I think it was great for all of us. So thank you again.
Thank you. Anytime.
All the help. Bye.